welcome to lesson 14. This is called missing numbers from subtraction problems. Now we did learn about missing add-ins in addition problems, and now we're going to be looking at it in a different perspective from subtraction problems. So this is going to give us a perspective on how we're going to approach our problems. I told you with the addition problems, we can think of it as a fact family. The same thing still applies with subtraction problems. We can approach it as a fact family, or we can approach it like this, where we have 3 plus 4 equals 7 when we read this problem straight down. But we could actually read this problem backwards as a subtraction problem, because that's how we do. That's what an inverse operation is. It's the complete opposite. So if I read it the complete opposite way, I can do 7 minus 4 equals 3. Now with subtraction problems, when I read up and down, it's still a subtraction problem. 9 minus 5 equals 4, but when I read it backwards, I include the inverse operation. 4 plus 5 equals 9. So that's how we're going to approach our problem. So starting with example 1, it says to reverse the order to create an addition problem. I have a subtraction problem. So when I read it from start to finish, left to right is how we normally read it. So it was start to finish. I read it as a subtraction problem, but when I read it backwards, I can create an addition problem. So I want you to go ahead and write that down in your spiral and see if you can get it. Your correct answer would be 23 minus, or plus, we are doing an addition problem, plus 45 equals 68. Now the same way you would actually still be correct if you were to do 45 plus 23 equals 68, because with the commutative property of addition, it says I can add numbers in any order and still get the correct answer. However, it is telling us to just reverse the order, so I'm just going from my difference, the answer, straight back. Alright, so example 2 says to reverse the order to create an addition equation. Same thing. Starts from top to bottom, read it as a subtraction problem, so if I go from bottom to top, I can create an addition problem. So your answer would be 54 plus 23 equals 77. Alright, now example 3 throws us for a little loop. We have a missing number in the subtraction problem, which is F. Again, it could be any letter, just like when we did in addition. It just means it's a missing number. We don't know what it is, so we're just going to give it a letter. So if 5 minus 15 equals 24, now if I read it backwards, just like we've been looking at it, reading it backwards, 4 plus 5 equals 9. So if I read this same problem backwards, 24 plus 15 equals whatever my number is, I already have my addition problem. 24 plus 15, 5 plus 4 is 9, 2 plus 1 is 3, so 39 is what F is equal to. I write F equals 39. Alright, and I know I can prove that answer by plugging it back in and doing 39 minus 15 has to be equal to 24. That would be proving my answer. Okay, now example 4 throws us for a little bit of a loop because we actually have our missing number in the middle. So if I were to go backwards or forwards, I would still have a missing number in my problem. However, looking at it down, top to bottom, I have 45 minus S equals 21. But when I look at 21 plus, because we're looking at it backwards, so it would be addition, 21 plus S equals 45. When we did our missing add-ins, if we have a missing add-in, we always subtract. So the way you can remember is if you have a number in the middle, in the gap, you're still going to subtract. I'm going to subtract the numbers that I already have, which is simply going to be 45 minus 21, and it's going to equal to whatever S is. So I'm going to put S equals 5 minus 1 is 4, 4 minus 2 is 2, so S equals 24. Therefore, 45 minus 24 equals 21. All right, you're going to be teaching with your partner today in class over the same lesson, and then you may get started on the practice problems. Thank you.